So as we use this tool, what's really important is that we measure our thickness wherever it is, right? Doesn't make a difference. We have to pull this guy to the end stop here. Pull it there, and then we lock it down, right? That allows us to move this portion and retain the measurement that we took. So in this case, if we were to go down on the rotor like this, we would push it down on here, and we would pull this back, and then we lock this down, right? And then we can pull this back, take it off, and then get our measurement here. The only real difference with this particular mic is that we have to start off with where the 0 mark is. So the 0 mark gives us our millimeters. You'll notice this one goes 0 through 60 millimeters. If we go down here and we take a look, you'll see that there's halfway mark. So each one of these hashes in between here represents 5. So you got 0 to 10, and then the middle mark being 5 millimeters, and then each hash in between there being 1 millimeter. So if we go down and look where the 0 lines up here, in this case, we would see that we're at, we start here at 20, 25, 26, 27, and looks like we're just about on the 28, but not quite there. So I would say we're at 27. And then what we want to do is we want to look at this bottom gauge. It's got the numbers 0 through 10. We're going to line up the next number. There's 10 lines here. So this, for example, looks like we're at 25, 26, 27. And then we're going to take a look here to see exactly where the next line lines up. In this case, it actually looks like right about here on the 8's lining up. So this would measure, right, 27.8 millimeters, which is very close to what we got with the digital mic. A different tool, very handy. The biggest thing that's nice about this is that we're able to release and come off of a rotor if it's got an edge that's higher than where it's worn down. And then typically what I'm talking about is the brake pad itself that sits in here, right? If we were to look at it kind of from the end, it doesn't cover the complete surface. No, I'd say 90% of it. So where this isn't pressing against it, right, those surfaces won't wear down on the rotor, but the edge in the middle here will all wear down, and what we're really looking for is that thickness where the brake pad touches. That's where the most heat's generated. That's our frictions. So let's start out with taking a look at our brake rotors here. So one of the things that we can see, and I'll put up some photos here, but we have quite an edge here on these rotors. I'll give you a demo. So here's my screwdriver, right, and if I just try to run it up, I can't get it past the edge. And if you can kind of get a little bit of perception on it, there's a little pocket here, but the lip that goes down in there is about half of the thickness of my screwdriver. So this is one of those situations where we might run into a bit of a problem. So if we were to use this digital one, right, these surfaces are flat, and so if I try to measure the thickness of this, right, and I go down on here, if I can get below the lip, I'm okay. And in this case, it looks like I can, but the problem is I have to measure it, and I can't pull it off because it's caught on those edges. If I pull it back, it changes my number when I take it off, and I've got the wrong number. Now this mic could measure this, and we'll compare it. So the very first thing I always want to do with a mic is I want to zero it out, right? I'm going to measure this one in metric, since I know our the metric system, since I know our spec is in metric. And I'm going to open this up and drop it down over the edge here, and I think you might be able to see it says 21 or 27.1, looks like 27.1. So we'll kind of keep that measurement in mind as we go to compare it later on. 27.1. Let's take a look at the other mic. That one's pretty easy since it's digital. This one, we will bring it down on here. We will bring our ends together. Remember that we will slide this to the edge. And now when I go to pull up and I can't get it up, I simply slide this back and off. And then I can try to get my measurement here off the end. Again, I'm going to follow the 0, so it looks like I'm at 25, 26. Looks like it's right at 26 on this guy. And then I'm going to look for the next line on here. I got to take a look at it so I can show you that lines up. In this case, it looks like it's at the 5. So this is measuring 26.5 millimeters, which is interesting because that is different than what we measured with the other mic. So let's take another measurement, right? Always a good idea to double check our measurements, but I have a suspicion why we're getting a variance here. And I'll explain to you why. Come down. Again, I'm going to come in 27.4. So this mic here seems pretty convinced that we're at 27.4, and that's almost a millimeter off of what I measured with the mechanical, right? So what's going on here? Well, we have to keep in mind that not all of this surface here wears completely even. So the highest point of this rotor is what this is going to pick up because it's got such a long surface that it measures across here. If you look, it's going to take in everything that this whole flat edge touches from this point right here all the way to the end. So the highest point's being measured. Where this one, the mechanical one, is going to measure in at a very specific isolated point on the rotor. And typically we want to take several measurements. What we're looking for is anything that looks like, so I'm going to release my lock again, pull this guy back, right? Not trying to squeeze too hard or anything, I just kind of lock it down, and then I lock this screw, and then I can pull this back to get it off of there easily. I'm going to take a look at it, and this one is saying 26.5 again. So this one's pretty consistent, the mechanical one. So what's happening is we've got high and low spots on the rotor, and so the digital mic that can't measure an isolated point is picking up the highest spot. And so I know just from experience that this is the right type of mic to be using for this type of application here. So we're going to use the measurement off of here at 26.5 in this case. All right. So the next thing that I'd like us to take a look at is brake pad thickness. So typically brake pads can be measured without taking the whole brake system apart, and this is why usually when a car comes in for service we want to check those brakes, right? We're looking to try to get those we're looking to try to make a sale, or not a sale. I hate that term because it sounds like we're trying to sell somebody something, but usually customers are paying for paying to bring their cars in for some kind of service. You know, it would be nice if we can warn them of potential issues. Okay, so now I want to measure the brake pad thickness, and I'll just kind of point this out. This is the backing plate, right here, and then this is the pad portion that we're trying to measure. This particular pad is what's referred to as the outboard brake pad, and then there's an inboard brake pad that sits on the other side. So if we take our gauges and kind of guesstimate, I call it, let's see where we're at. I'm going to start off right here with the 3 millimeters, and look at that. So this, typically, if you can imagine, you're able to stick through the rim and kind of get it down in there and get a good gauge of what the brake pad thickness is. Now, at 3 millimeters, that's getting pretty low. I've also got this big lip. We'll have to compare those numbers and see where we're at. I can tell you these rotors on this car are not able to be machined according to factory recommendations, and there's a bunch of reasons why. It has to do with it being a vented rotor and the thickness, And anyway, so this one, if this lip here bothers me, because what happens is as this lip gets worn, if we were just to put brake pads in there, now the brake pad can walk back and forth as this thing rotates over it. Like a corral, you know, if it was following water, the rotor is going to follow the track of this circle. The problem with that is that movement of the brake pad is that scrubbing back and forth as it walks around, as the wheel's turning,